Everyone, can you hear me well? Right at the end. Cool, so I'll be talking about pandas 2 today. How many of you use pandas? This pandas 1? Okay, cool. It's going to be a bit of a technical talk because if you try pandas 2, you'll see that the differences are subtle. I think that's I think that's true for most of the recent, probably for like the last 5 or even 10 years of pandas, like the differences between releases are not huge, so even if it's pandas. So yeah, I was saying I'm gonna talk a bit about Apache Arrow, that it's something that as pandas users, unless you're doing very fancy things, you in general don't need to know much about it, but it's good that you know for a few reasons. And then I'm gonna focus more, like the last part of the talk, on pandas 2. What's new related to Arrow, to what all the context I'll be giving before, like other things that we deploy with pandas 2, and just few ideas for the future that I'm not sure if there will be plans or not, because we, as core developers, we're probably as uncertain as you as users what the future will look like. So talking about data frames, you probably know that. But yeah, a data frame is basically if you're used to databases, like a table in a database, that's the general idea. It's like a two-dimensional data structure that every column has the same type. That's the general idea. Suppose if you use NumPy, for example, that's like a multidimensional array that all the items have the same type. Like in data frames, every column has different types, and it's usually compared to things like NumPy, you will have like probably more different types. Like you will have the strings that are not so common on NumPy and few other things. And also, like when we talk about data frame, and people will use data frame, like the definition of data frames, in different ways, but we usually talk like not only the data structure but all the operations that we implement. So that's why they are useful, everything that we do with them. So this is how I would define a data frame architecture. You might see different things. What I'm representing here, can you see more or less? Is it big enough? Okay. So what I'm representing at the very top is like how data is represented. That's something that as pandas users, particularly when you're starting, you don't care that much. Like you just want to know what you can do with your data and how to visualize it, but you don't care that much about how this data is represented in memory. But the data is loaded in memory when you do a read CSV, read Parquet, read SQL, whatever you are loading. This data goes to the memory, and it goes to the memory in a specific representation. That's like this, literally the zeros and ones that will be represented in your memory. That's what I'm representing in the first row, only how it looks like. Then in the second row, I'm representing like what you can do with this data. It's of course pretty related to the how it is represented, like, because you are going to do these operations on the memory. And finally, the part that you are probably more familiar and the part that you care more about is like what's in the like the user experience for the users. Like this icon at the very bottom represents the users. That would be probably you, and this is the way how you interact with pandas. And here I'm not only representing pandas, I'm representing like different, like you're probably familiar, or at least you've heard like PySpark, Polars, like R, like from different languages, even like Julia have data frames there. It's like as many as you can imagine. All of them represent operations, and all of them save the data in a very particular way. So the most obvious question you can ask, I would say, is like, okay, what? Like all this complexity, like the first box is representing literally a Python list. That is what you could use to represent all these or a dictionary or one of these Python structures. Here the problem that we've got with that is that they are optimized like for being convenient, for being flexible. You can mix types if you want. You can append pretty as easily as you can query the data. But for doing computations at a scale, they are small. And if you see this example, it's something like in NumPy, that it's like one of the alternative representations that we had in that there, is like taking milliseconds, something that in lists, like I think this is like a 10 million element list. And yeah, you can see that it's taking 6 seconds. You will start suffering from this. Like imagine that you are doing this and you are doing this for a data frame that has like 20 columns. 20 columns times 5, it starts to be like pretty slow. We cannot do much. And of course, like This is just doing like an exponential. We do much more complex operations. So yeah, Python list doesn't work for us. If they work, like everything would be much easier. Like pandas would be like super easy to implement, and yeah, everybody would be happy. So the next thing, I'm not sure if many of you have heard about this, the import array. This is in the Python standard library. Did someone work with that? Is anyone familiar? No, not even a single person. Okay. There is a reason for that. I mean, this is a much more efficient container. It's more like a C array, so it's much, like the representation is much, let's say, much more efficient, but it doesn't bring any operation. So pretty much you cannot do anything with it. That's the reason, probably, like, even if it's in the standard library, you don't know about it because it's like pretty useless in general. So this takes us to NumPy. And NumPy is pretty much what Pandas has been using until now, and it's still using. So NumPy is a memory representation similar to array, pretty efficient. You have like only one data type for every list, which means that the operations are much faster. Otherwise, for every item, you need to store the type, you need to store like garbage collector information, like Python does. And in this case, it's just like this representation. It's representing literally like the just numbers, and that's extremely fast because it's like all the CPUs are designed for use the cache, for everything that works. So this has been working pretty well, like everything that you did with Pandas is working with that. It comes with some problems. Like NumPy was designed with numbers in mind, for float, for integers, particularly for linear algebra operations. It was never designed so much for strings, for datums. There is some support, but the support is not great. And this means like Pandas was decently fast for anything numeric, but it was pretty slow. It's been pretty slow for those things. So, yeah, another point is like you can extend those. Everything that we're doing in these operations, besides what NumPy provides, we are implementing mostly in Python. You can also implement in C, but it's like NumPy is like kind of a standard, but inside of the Python community. So this takes us to Apache Arrow. That is one of the things that we've been working on for a few versions. So it's efficient, again, it's like NumPy, it's like the array module that we use. It can provide operations, and the nice thing is that it provides an ecosystem, like Arrow comes with some, but the general idea is like you can have different implementations of operations. It's really like the container that is defined with a specification, with a standard, so you know exactly how the data will look like, and you can implement your own operations. And you can share them, and the idea is that eventually we'll have like a pretty nice ecosystem of data operations for Arrow. Arrow was designed with data frames in mind, so literally supports any type that you can, as far as I know. I mean, there might be very specialized type for domains and that, but you have the strings, you have amazing support for dates, you even have nested structures. If you have one column of your data frame is a list or is a dictionary, you have all those things, it's built. Also has pretty amazing support for missing values, but it's something that in NumPy it's a bit trickier, and as I say, that like you can extend it, and you can extend it in any way you want, because literally it's a specification. Besides implementations, and there are several, and we're going to see about this. Like you can literally implement anything, whether you're in the Python or you're not. So what's new in Pandas? I'm going to start a bit more from technical issues. So what's in Pandas 2? What's the main difference? And it hasn't been added everything in Pandas 2. It's like a work that has been done, and we'll see in a second, like in different versions of Pandas 1, but Pandas 2 might mark an important milestone. It's like we still have NumPy arrays, we still have the NumPy operation, we still have the Pandas operation, but as I mentioned, it's like some things that we implement in Python that NumPy doesn't provide for us. But we start to use Arrow as a backend. That's something like when you have a data type, you will be able to decide like, okay, do I want to use an integer that it's NumPy or an integer that it's Arrow? And there are differences. As I say, for integers and float, the difference won't be huge. And actually, in some cases, NumPy would be better. I think in general, Arrow will be better, at least in the long term. But the difference should be subtle. But for strings, for example, Pandas strings are already faster because we've been using Arrow for a while. That was the first use case of Pandas. And in pandas 2 in particular, we start to implement more the arrow kernels. There was some support for arrow, pretty limited. It's still limited, it's still not as mature as NumPy. You will see that many things in arrow might be slower. Still in pandas 2.0, this will keep changing, as it's like a pretty huge change. But yeah, like we're getting there, and the pandas 2 already provides like many operations that work pretty well with arrow. Going a bit more into the details of arrows, I more or less name them. But yeah, like the most important thing probably is the new types. As I said, like NumPy, if it was only integers and floats, we would be in a pretty nice position. But that's not the case. Like users have things like categories that it's like strings, but with a very subset of values, for example, the list of countries, and you can represent it much better if you're using categories, because you will have, like in your data, you will have numbers that are much faster than the strings, and then you will just have the lookup table of saying, okay, this string, this integer belongs to this country, and whatever. And yeah, many more, even binary. I don't think NumPy has any support for binary types. Like in Arrow, you will have nested types, as I say. Like so, you have like many more options for types, and with good support. Like not just like because NumPy does support the strings. The only problem is that NumPy strings are super slow because literally they are pointers to Python strings, and Python strings, as we've seen before, it was like the order of magnitude of 100 times slower. I don't know exactly for strings that's exactly what you would get, but yeah, like it's still pretty slow compared to what you can get. Then missing values is a tricky thing, as you probably suffer from that. Like missing values in general are used the NaN, the not a number from the float, but that's a part of the float specification. There is no other data type. Like in Python you have none, but for a data type in a number, for example, in an integer, you have like these C structures where every number is represented in the C, like zeros and ones, not fancy Python stuff. You literally don't have a way to represent nuns. Like what you need to do in practice is to have a separate array where you are specifying which values are present and which are not. And Arrow supports that. While NumPy, what we were doing in pandas, and I think it was a very ugly hack, but like every time you want a missing value and an integer value, we convert this to float. Probably you suffer from that because I don't think this is like very nice and it's pretty difficult for the users. And then I think the most important one is like the ecosystem. As I said, like Arrow is designed as a standard. I don't know if it will be a standard, but it will be one of many standards eventually, like happens with all the standards. Like it would be extremely fast. Like for example, like polars and pandas, if you are moving data from one to the other, like if pandas is using Arrow, we'll be able to do this immediately without copying any data. The same data would be used by polars, by pandas. You can access like from both at the same time, keep changing from one library to another, and this could even be possible from other languages. You would have like an R data frame, and literally from R start using this data. This is not important if you're having a data set with 100 rows. You probably don't care anything about this, and anything will work. But if you have like few terabytes or few gigabytes of data, this starts to be pretty relevant. Like we're talking from milliseconds, orders of magnitudes to minutes or hours or even days. So the difference is pretty big. And yeah, there are several. I was mentioning like Arrow is not designed for Python. It's like a cross-language thing. You can access from any place, and there are implementations for possibly every language you can have. Juliet, JavaScript, to R, in Rust there are two implementations that eventually they are probably going to merge, but at the moment there are two. Probably the main one is C++, but yeah, they're all pretty good, at least the ones I tried. And for pandas 2, as I said, like Arrow is not coming in pandas 2, it's been coming like for a while. We started in 0.23, I think that was like probably 5 years ago. We started adding like more extensions for, instead of wrapping just NumPy, we were able to start to customize things a bit. Then we added the string data type, that is probably the most important one because it's much faster. And I don't think it comes by default yet, so if you want to use the Arrow strings and you want to get like this speed, you need to define like that your string columns are Arrow packed, and you need to define the data type string. You won't get that out of the box for now. Like then in 1.5 we started to have support for numerical values, also in arrow, and then in 2.0 we're bringing all the arrow types, and we start to use more the kernels, because in some cases we're using arrow types, but when you want to do operations, we didn't have the arrow implementation of the operation, so we were converting them back to NumPy, which is not great. And in Python 3, hopefully we'll have like good arrow support for everything, because now there are some operations that are slower. I think like group by, for example, I think there is some work like in the recent days, but yeah, group by, I think at the moment, if you have arrow types, is slower. You will find a few of these things. There are, yeah, I think I mentioned, yeah, one of the things that I didn't mention is like the loaders also. When you're loading from a CSV, from a Parquet file, you can get directly the arrow types now. This is something that before pandas 2.0 you couldn't do. Like before that, you had to specify specifically like convert the types after you were loading. That's not ideal. You can literally take like the data from the file and import it into arrow. As I said, for numbers it doesn't make a big difference, and actually you can even get zero copy line. You can get your data loaded like from NumPy, or convert from NumPy to arrow without changes, because the representation is very simple. But for things like strings, the representation in memory is extremely different, so you will have to copy all this data after you load it. So that's a pretty big change. A few other things shipped in pandas 2, not arrow related. I think the most relevant one is that everything that was deprecated, that thing that we wanted to get rid, it was warning to you in pandas 1. I don't know if you were using any of them, you were supposed to keep fixing these warnings by using the new syntax, the new way of doing things. If you're migrating to pandas 2 and you have code that is generating these warnings, it will take basically in pandas 2. So you would want to first upgrade to pandas 1.5.3. the latest version that we've got, and then when you have your code running without warnings, then you should be able to move to pandas 2 and you should be safe. There are a few things that would still break, but I think they are very rare, and it will be pretty difficult to find. Another pretty important thing is like support for non-nanosecond dates. Dates in pandas were like having nanosecond precisions. You would represent, like, it didn't matter if you were representing dates or dates with the hour, dates with the hour and minutes, whatever. You had like nanosecond precision, and this had a main issue, that is that the amount of dates that you can represent, the range of dates was pretty limited. So you couldn't go to say like, okay, this happened in my data set, I had this column that is representing the previous century, and that was out of range, and it didn't break. Now we have a new data type like precision for seconds, that basically you can represent from the Big Bang until a time that probably we don't care anymore about. Then there is work on copy and write, that it means literally that we're making less copies internally. When you are doing operations, in many cases we keep copying data, now it's getting less of that. To date time, if you're converting things to date, there was some magic there that we removed. This is pretty relevant for the users working on dates. In some cases we had a column, and some columns were assumed that the day was first and the month later, and then the month first and the day later. That was like it hassle, and it speaks. And then if you want to install a few optional dependencies, you can do that via pfly. It's relevant for many of you. So a few ideas for the future. As I said, like, this is not future plans, it's not approved. Like, we are more than 20 pandas core developers, and we pretty much disagree on everything, at least initially. So I cannot tell you which is the direction that we're facing, but yeah, some opinions and some things that it's not pandas related, but it's like the goal. I think ideally what we would like is to converge more into Apache Arrow. It's been designed as a standard, and I have the ++, not because of C++, but I think it should be like an extended version, an improved version of Apache Arrow. There are many things that Arrow are doing great, and many things that can be better. I think, like, for example, sparse data in Arrow are not that great. I know that actively I think has few changes in the Arrow specification for performance, things that make their life easy, and there are a few things here and there are a few assumptions that can be improved, and I think like Apache Arrow will be slowly improving as it goes, and I think everyone should like be converging into that in the data frame space. Of course, if you are using NumPy, that's a different use case. That should be under issue. Then we should be converging into the algorithms. There is no reason why when I'm taking a column and saying I want to multiply it by 3, or I want to do a group by, or I want to do whatever. You need to have like an implementation for every different library. I think it's great to have the APIs. I think the APIs are there to stay, and probably we want more. I think it's good to have this choice of, like, I think Polars is much better API for many kinds of users. I think Pandas is good for other kind of users. I think like there are many people coming from a software engineering background to this field, but there are many people working in science and they don't care that much about computing. I think different APIs are good. I think it's good that they stay, but if we have a super fast implementation of an operation, I don't think there is any reason why there should be duplication. I think they should be converging into what is called the arrow kernels. I don't know if the name is great, and I don't know if that would be how it's called, but I think like there is not much reason for having like duplicating all this effort in the community. And here I'm talking also about other languages. You have a super fast implementation, everybody should eventually go and converge into using that. And I think then the domain operations, there are many reasons like why you want to have like things specific for your business. If you're working with, I'm working recently in molecular data, that's something pretty specific. I don't think it will be part of an implementation, but it will be something domain, but there is no reason if I have like an algorithm that is great at extracting data from molecules, why someone else in the open source community would like to implement it again if it's already available and it's open source and anyone can use it, as I say, from not only from the Python data frame library, but from any library. If I extend this, I think like one of the couple of things that can be improved is also the I/O. There is no reason why you're reading a CSV, like that you want to have 20 different implementations for that. There are reasons to have them because like in some cases users want magic. They want to say like, okay, open me this rich CSV and make all the decisions for me, load everything as like make any decision, invert any date time, invert anything. There are users that see a lot of value in that. If you're in a Jupyter notebook, I think that's everything, and you just want to compete on Kaggle with the Titanic data set. I think you don't want to start specifying schemas. If you are building pipelines, if you're a software engineer, you probably want to specify the schema. You don't want your software to one day think this is a date, and the other day think this is a number, and the other day think this is a string. I think you want to be very specific on what you want. So I think different users have different needs, but when there is a good implementation from the API point of view, I don't think there is any reason to just like say, oh, Polars need to have one implementation of rich CSV, Pandas needs another one, like R needs another one. I think we should probably converge into that. And also for plotting, I think plotting plotting from data frames is something that if you have a good plotting library and at the end of the day we just have columns in all these libraries, I think we should be able to reduce a lot of this code. And this is my last slide, going a bit fancy with future plans. I think probably a bigger revolution than the arrow revolution, that I think it's making like a lot of progress in terms of the representation in memory, is getting the data before it's into memory. Like I'm gonna mention an example, some of you are familiar with this, but imagine that you have a CSV with all the information of whatever in the whole world, and you only care about the data in Lithuania. So the Pandas way of doing things is like you do a rich CSV, you load all your terabyte of data into your supercomputer memory, like I don't know how much memory you need for that. And then basically the first thing you do after that is filtering and saying, okay, I just want Lithuania. If you think about that, it doesn't make any sense. I mean, it makes much more sense to just, when you're reading the CSV, anything that it's not about Lithuania, that doesn't have the column country, it's not Lithuania, you just discard it, and you actually don't need so much memory. You're making your terabyte maybe 1 gigabyte or whatever. Right? That makes much more sense. And you can do many more of those things. So that's what usually it's called the out-of-core algorithms. And I think being able to implement the algorithms there and locking the data after loading into memory has a huge potential. I think like in terms of performance, that's like a huge difference. And there is work, I think Polars is doing amazing work on that. Active is going in that direction. I think they are starting, but they are doing a pretty amazing job there. Then I say like the I/O should be reduced. In many cases, you want to have the data in memory. There are 1,000 reasons also for that. You cannot do everything out of core, but yeah, you should have that. And then there is this query plan concept that it means literally when you have one of these APIs and you are saying to your data frame, okay, I want to do this, I want to read from this CSV, or well, CSV is a pretty bad format. If you can avoid CSV in general, I mean, if someone else is giving you the data, like just open, whatever. But yeah, I'm using CSV as an example because I think it's by far the most popular, at least in the pandas docs. It's one of our top page. But yeah, if you're going to save the data yourself, just use Parquet or something else because it's a pretty but yeah. Going back to that, if you're reading from CSV, you are filtering and you're computing some column and that, like there is a lot of value in doing that like in 2 steps. First, getting everything like into this query plan and then executing it because you can optimize a lot. It's like the same as if you're going shopping and someone is telling you, okay, I need bread, I need milk, I need whatever. If they tell you one thing at a time, you're gonna go like 20 trips to the shop to get every single thing. Doesn't make sense. If they give you the whole list, you're gonna go and get everything and optimize much better. You're gonna do one time in every area in the supermarket. So that's more or less the same idea. So it's pretty much it. So this query plans, there is also work on that. There is something named Substrate that the community is trying to converge into, and hopefully we'll see some more work in there. And that's everything from my side. Thank you.